Welcome to Video Lectures, Section 1.4, Fractions. The first problem we're going to work with is only found in Part A, numbers 1 through 4, where we're going to just find different names for a fraction. To do this, we're just multiplying the top and the bottom, or the numerator and the denominator, by a common number. So I'm going to go ahead and start marking with my felt tip pen again. And here we're just gonna, I'm gonna use the dot to show for multiplication. Some of you may not be comfortable with that yet and you would like to use the times sign. That's fine, as long as you do the exact same thing to the numerator as the denominator, and you just pick any number you want. I'm gonna go ahead and start with 2. So I have 2 right here, 2 times, or you can use the multiplication sign like an X, times 2, and this makes 4, and then multiplying the bottom, 5 times 2 makes 10. And we're trying to find 4 different fractions, so that's the first one. The next one, I'm going to multiply the top and bottom by 3. And so my next one will be 2 times 3, which makes my next fraction 6, over 5 times 3 is 15. And so that's my second. Go ahead and erase, oops. Sorry, I erased too much. Oops, we'll just put it back in there. 4/10. I meant to erase my 3's here. There we go. Okay, now I'm going to go ahead and multiply by 4 to the numerator and the denominator, which gives me 8/20. And I only need one more for my 4 different ones. So now I'm going to multiply by 5, which gives me 10/25. And I could have picked any numbers I wanted. I could have done 100, and then I would have had 200 over 500. It doesn't matter, it just wanted different names for the fraction. So that was only found in Part A. Let's move to the next one. Again, only found in Part A, numbers 5 through 10. This part goes through simplifying fractions. So in the first example, we were multiplying the numerator and denominator by a number. In these examples, we're going to be dividing the numerator and denominator by a common number. So I'm going to divide the numerator and denominator, and again, I apologize for my handwriting. Writing on a computer is a little tough. So I'm going to find what goes into both 75 and 100. I know that 25 will go into both. Now, some of you are not comfortable doing that. That's okay. You can go through and divide it over and over until you get it down to a point where you can't divide it anymore. And I'll show you how to do that in just a second. So what I'm going to do is, I know 25 goes into 75, and some of you might think of this in money terms. So you have 25 or a quarter in America, 25 cents goes, 3 of those make 75, so that makes this 3. And then the bottom, 100 divided by 25 is 4. Now 3 and 4 is as far as it'll go, so that is simplified. But if you're not comfortable with that, you can go ahead and try dividing by several at a time. So okay, so if you weren't comfortable with dividing by 25 right off the bat, you could go ahead and divide by several things. So let's say I see that 75 ends with a 5 and 100 ends with a 0. So I know both of those are divisible by 5 because if it ends with a 5 or a 0, it's divisible by 5. So I'm going to go ahead and say, okay, divide this by 5 and divide this by 5. 75 divided by 5 is 15, and 100 divided by 5 is 20. Okay, but I also notice again that 15 and 20, those are both divisible by 5 again. So I'm going to come in here and divide by 5 because I'm not done all the way. And I have 3, and 20 divided by 5 is 4. So either way, I end up at the end. So um, you can go different ways to figure this out. The next one, I have to find another common divisor. So what'll go into both 12 and 54? If you're not comfortable finding a large one right off the bat, you can start off small. It seems that I left my answer here instead of over in my answer key. Okay, so I'm going to let you just kind of think about what you know goes into both 12 and 54. And it doesn't have to be the largest number. It doesn't have to be the greatest common denominator or the greatest common divisor. You can use whatever you would like. Some of you are going to say, I'm going to start off small and just divide the top and bottom by 2 because I notice they're both even. And that's okay. Some of you will say, I think 4 will go into both of those. It's totally up to you. Right now, though, I know that 54 is 9 times 6. So if I divide this by 6, 12 is also divisible by 6, which makes that 2. And the bottom, 54 divided by 6 is 9. And there we go, which is the answer. If you're not comfortable with that though, go ahead and divide it by 2 at first and then see what you get, and you can keep dividing. Clear down until you end up with the smallest fraction where nothing will go into both the numerator and the denominator anymore. So let's go ahead and move on to the next one. These next ones are similar to Part A, numbers 11 through 13, and B, 1 through 3, where we are going to try and create a common denominator. So our first one says find this one with the denominator of 50. So our denominator right now is 25, and we need to know, what do I multiply to 25 to get to 50? This one's kind of nice. 25 times 2 makes 50, which is great. Now remember, whatever you do to the top, you have to do to the bottom, and whatever you do to the bottom, you have to do to the top. You have to keep it balanced. So if I multiplied the bottom by 2, I must also multiply the top by 2. And 2 times 3 is 6. There we go. So my answer is 6/50ths. The next one, number 5. I need to think, what do I multiply to the 10 to make 50? Again, this one's not too bad. I just need to multiply it by a 5, and I get 50. And whatever I do to the numerator or denominator, I must also do to the numerator or denominator. So I must multiply the top by 5 to keep it balanced. 5 times 4 is 20, and I've now created the fraction with 50 on the denominator. So 20 over 50. Let's move to the next one. Adding and subtracting fractions is probably one of the most difficult parts of this assignment because you have to find something called the least common denominator, also known as the least common multiple between the two numbers, which can get kind of frustrating for some people. Some of you will just look at these and just know the number that both of them will go into. Some of you might need to take a little bit of time to work through it. There's lots of different ways to find the least common denominator or the lowest common multiple. One way, some people just multiply these two together and that gets them a common multiple, but it might not be the smallest. And if you do that, you have to reduce at the end or simplify. If you like that way, go ahead and then just remember that you need to simplify which would be up here. My method prevents simplifying. It gives you the answer um, in the lowest terms possible. Oh, I'm going to show one other way. Some of you might like this way, which would be here's 6 and here's 8, and we need to find the smallest number that both of them will go into, and you just start making multiples of those numbers until you find something in common. So 6 times 1 is 6, so I'm just going to leave that. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. 6 times 6 is 36, and so on. Now I'm going to go ahead and do the 8s. 8 times 2 is 16. 8 times 3 is 24. And I can stop. Right there I see I have a common denominator or a common multiple, and I want the smallest, so 24 is perfect. So what you do is you just start making multiples and then you find the smallest one. And some people will like that method. So get rid of this here. I'm going to go through a different way, and if you don't want to use this way, that's fine. Go ahead and press fast forward in the video so it doesn't take up your time. This way is finding all of the factors and making sure that all of the factor trees are taken care of. Anyway, we'll get there. The first way I'm going to do it is more analytical in what you might read in a math book. And then I'm going to give you kind of a silly way to help remember it, and it's totally up to you whichever way you want to. Some people think it's silly, the funny way, and that's fine. You don't have to use it, but I like mnemonics because I think it helps things stick. So the first thing I'm going to do is the mathematical or analytical way that you would probably see written out in a math book. So this is the factor way. What we do is we make a factor tree, and you do two little kind of carrots saying I'm going to break down this number and what goes into it. So 8 is 2 times 4. 2 is a prime number, so you circle it. 4 breaks into 2 times 2. 2 is prime, so you circle it. Then you go to the next denominator, which is 6, and this is 2 times 3. Both of these are primes, so you circle them. You now have the prime factorization of both of those numbers, meaning that you've broken it all the way down to the very small prime numbers, 2, 3, 5, 7, 11, 13. These are all prime numbers. And when you get down to one of those, you circle it and you stop because nothing else will go into it. That's a prime. Okay, so the mathematical textbook way says you take the largest number of prime numbers that occur in one denominator. So what we do for the least or the lowest common denominator, I call it the LCD. I go through and I find every single different type of prime factor. In our case, we only have 2's and we only have 3's. Now, the definition said find the most times it occurs in one denominator. So I come over here, the most times it occurs are in the 8, and it occurs 1, 2, 3 times. So this means I need 3 2's. And I know I'm kind of jumping ahead and I'm throwing in an exponent, and you won't cover that until chapter or the next section, section 2.1, but I think some of you might have a little bit of background on that. That just means that I have 3 2's. Then I come and I see the number of times I have a 3. I only have 1 3 in this denominator, so I only need one of them. Some of you are saying, but wait, there are 4 2's here, right? But remember, the definition said the largest number of times it occurs in only one denominator. You can't take them all, you just need one. So this is 2 times 2 times 2, which is 8, times 3 is 24. And that's the smallest number that both 8 and 6 will go into. So that's a second method. The funny method that I go through is called Cookie Monster method, and it's the exact same way as what we just did, except that it gives you kind of some fun to it, so that it gives you kind of a mnemonic to help you remember. So I'm going to erase all of this. It's the exact same way as the prime factorization method that we just finished. It just helps keep things in order. So I'm going to come through and erase this quick. And I need some different colors. So it kind of coordinates things as well. Again, we're going to still break up the 8. But instead of calling these factors, these are now cookies. And I'm going to call all the reds are going to be, or all the 2's are going to be red. So I'm still breaking this down, prime factors, and then I'm going to come up here and break down the 6. 6 is 2 times 3. Now stop. 3 is a different kind of cookie, so let's make it blue. I'm going to circle it there. You know, the whole thing's in red, so maybe we should circle the 2's in green. Okay, now this is where the Cookie Monster method comes in. All we're doing is just making a fun story about it. So Cookie Monster's mom is trying to teach him manners. And so Cookie Monster can only take one plate for every type of cookie. So I know it sounds silly. The least common denominator. So Cookie Monster has 2 plates, the 3/8 plate and the 1/6. But he can't take both plates. That would be rude. He can only take one. And the different cookies that he has are 2's. I guess I should use the color. Let's get green. There are 2's or green cookies, and then there are 3's or blue cookies. And so if Cookie Monster can only pick one plate, which plate would he pick for the green cookies? He's going to pick the 3/8 because there are 1, 2, 3 of the green cookies on that plate. But remember, he can't take both plates because she's teaching him manners. So he doesn't include this. We don't include this one because it's on the other plate. Now, Cookie Monster's mom says, now you can pick one plate that you can get the blue cookies. Well, there's only one blue cookie, so he's going to pick this plate, the 1/6, and get his one blue cookie. There we go. And now we're done. We've gone through all of the different cookies, and this is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So what we did was 2 times 2 times 2. These two will make 4. Add it, or multiply your next 2, which makes 8 times 3, which is 24. So we have lots of different ways to figure out the least common denominator. I'm going to go ahead and erase this again. Now that we know that the least common denominator is 4, or 24, pardon me, get this out of here. Now we need to make those denominators 24. Let's come in and do red because you can see that pretty well. So we have my 3/8, and I need to make this denominator 24. So I need to multiply the 8 by 3, and I'm going to work vertically, so I'm going to come down here, which makes it 24. But whatever I do to the top or to the bottom, I must also do to the top. So if I multiply 3 to the denominator, I must also multiply 3 to the numerator, which makes this 9/24. Now I'm still adding this 1/6, but I need to make this also 24 on the denominator. So here I multiply by 4 because 6 times 4 is 24. Again, you must also do the numerator. So I get 4. Now I'm going to add these together. 4 plus 9 is 13 over 24. Do not add the denominators, only add the numerators, and you're done. Some of you are thinking, well, why don't I add the denominators and get 48? Remember, if I'm adding something like 1/2 plus 1/2, if you have half of a pizza and half of a pizza, add them together, you get 1 whole pizza, or 2 halves, which is 1. So if you have if you're having a hard time remembering if you add the numerators and what do you do to the denominators, always go back to something simple like 1/2 plus 1/2. So we can delete that or not. There we go. Delete this all out of here. Okay, so my answer was 13/24, and it matches. Okay, so let's kind of break that back down really quickly. You want to find step number 1, find the least common denominator. Any method you want works just fine. Some of you might prefer just finding a common denominator, which is multiplying both of the denominators together, but in the end, you will have to simplify, and that's up to you. If you would like to just find the common denominator, in the end, you have to simplify. Simplify. Okay, step number 2. Do what we did up here, which is create the fraction with the new denominator. So down here we created these new denominators. So multiply to top and bottom by, sorry for my handwriting, by the number, and I'm going to use a number sign, to get the equal the lowest common denominator, or the common denominator if you prefer that method. Number 3, add or subtract the numerators. Do not add the denominators, you keep them. Now, if you have done it by finding the lowest common denominator, you do not need to simplify. If you have just done the common denominator, you need to add step 4, which is then simplify. Okay, let's move on to the next one. If you feel that this was a little too much, go ahead and rewind it and rewatch number 6 again in any method that you prefer. Okay, number 7. We're now going to start adding and subtracting with mixed numbers. The first thing you need to do, make them improper. So the first thing to make them improper is taking the denominator, multiplying it by the whole number, and then adding the top number. So I'm going to put that in here, 7, 5, 1. We multiply and add, and you make a clockwise circle like this. So we start at the bottom, 5 multiply 7, add 1, and you do a counterclockwise circle. So 5 times 7 is 35, plus 1 makes 36, and then you keep the denominator because that was the denominator. They're kind of the what it's divided into. So we have 36 fifth pieces. Okay, let's try it with the next one. 4 and 2/15. Remember, we're going to go start at the bottom and do our clockwise circle, multiply, add. So we have 15 times 4. 15 times 4 is 60, plus 2, we're going to be adding 62/15. Okay, now we're going to look at the denominators and find the lowest common denominator. In this one, it's actually pretty nice because 5 will go into 15 evenly, then this one is the lowest common denominator, 15. So I just need to multiply my first fraction by the number that will make the bottom, or the denominator, 15, which is 3. So we're going to multiply by 3 and multiply by 3. So that gives me a denominator of 15. And this one is already 15, so we don't have to do anything to this one. It is perfect. Now 3 times 36, because this isn't something that I have memorized and it wasn't on your your multiplication monster, let's go ahead and do a little calculation off to the side. 3 times 36. 3 times 6 is 18. 3 times 3 is 9, plus 1 is 10. So 3 times 36 is 108. Okay, so now everything looks good. I have the denominators that are the same. Now I can add these up, which makes 106 plus 62, 8 plus 2. If you're not okay doing this horizontally, you could go ahead and do some math off to the side, a little bit of scratch work. I'm going to come over here and add. So this is just scratch work. We need to add 62 to 108. If you need to do this off to the side, feel free. If not, you could go ahead and add that vertically or horizontally. So we get 8 plus 2 is 10. Carry the 1. 1 plus 0 plus 6 is 7. And 1 plus nothing is 1. And then we have the bottom. Keep that as 15. And now I have 170 over 15. Quickly, I do notice that these end with 0 and 5. That means these are both divisible by 5. So I'm going to hurry and do that to simplify it. 15 divided by 5 is 3. 170 divided by 5 isn't something that I have right off the top of my head. So again, I'm going to need a little bit of scratch work. I'm going to go ahead and erase a little bit over here to give me some room for some scratch work. Hopefully on your paper, feel free to keep your scratch work handy so that you know if you've made any mistakes or not. I'm simply doing this because I have limited space that I've given myself for this. So I need 170 divided by 5. Okay, 5 will not go into 1, so I need 5 to go into 17. I know 5 times 3 is 15. Subtract gives me 2, and then I bring down the 0. 5 goes into 20 evenly at 4. 4 times 5 is 20, minus a 0, so we're good. So this top number over here, 170 divided by 5, simplified, gives me 34. So my answer is 34 over 3, but that's an improper fraction, so I should probably change it to a mixed number. To do that, you divide and then take the remainder. Some of you are okay just dividing that in your head, knowing that 3 goes into 33 11 times. If you're not okay with that, go ahead and write it down. Use your paper. This is especially important for tactile and visual learners. Go ahead and write it down. Okay, so 3 will go into 3 one time. 1 times 3 is 3. I subtract and add 0. So I bring down the 4. 3 goes into 4 one time. And 1 times 3 is 3. Subtract is 1. So we have a remainder of 1. So it goes in 11 whole times, with one remainder, so I put that over the denominator, and I'm left with 11 and 1/3. You can always check this by doing your clockwise circle. 3 times 11 is 33, plus 1 is 34, and you keep the denominator, which is 3, and it matches the same, so both of these are equal. 34 thirds is the same as 11 and 1/3. Okay, let's move to the next example. 6/14 minus 3/4. Okay, so now I need to find what will these both go into. Oh, I need to address something really quickly. Some of you may say, why did I have to simplify in this right here? I had to divide by 5. Why did I have to divide by 5 when previously I had said if you find the least common denominator, you shouldn't have to simplify? The reason for this is that we could have simplified the 62 over 15 before we moved on, but we didn't, so go ahead and simplify at the end. Okay, so we have 6/14 minus 3/4. So again, we need to look for a common denominator. Use any method you would like. You can go ahead and list them out. 4 times 2 is 8, 4 times 3 is 12, and so on. Or you could just multiply them together and get the common denominator. If you do that, you must make sure that you simplify at the end. Let's go ahead and I will tell you right now, after using your method, whichever way, I'm going to go ahead and do my way. I like the Cookie Monster method, finding all of the common denominator, or all of the prime factors. 14 is 2 times 7, and 4 is 2 times 2. So I need, for the lowest common denominator, 2's and 7's. And I can only pick one of the denominators, so I'm going to pick this one, and it has 2 of them. The 7, there's only 1, so it's 1. 2 times 2 gives me 4. 4 times 7 is 28, so the lowest common denominator is 28, which means I need to change both of these denominators to be 28 on the bottom. So I have my 6/14. To make this 28, I just need to multiply by 2. And I must make sure that I multiply the top, or the numerator, by 2 as well. So I end up with 12 over 28. Now I have that one, and I still need to work with the 3/4. This is missing. I need to multiply the 4 by 7. So I need to multiply the top and bottom by 7, and I get minus 21 over 28. Okay, now I'm ready to subtract. Notice 12 is smaller than 21. 12 subtract 21, so I know this one's going to be a negative sign. And in the instructions, it always says put your larger number first and then go back and find the sign, positive or negative. So we're going to go ahead and think of it as 21 minus 12. 21 subtract 12. If you need to borrow, go ahead. Those of you who are okay just subtracting that know that it's 9. And then do not add and subtract the denominator. You keep it, so it's 9 over 28. But remember, the 21, it said minus 21, which means I'm going to end up in the whole, which is negative 9/28. Another way of thinking of that is that you had a positive $12 uh, and you're subtracting 21, which means you're going to go into the hole because you don't have enough. And so that's one way of thinking about it, is in money terms. Okay, let's move on to number 9, which I believe is our last example. Yep, because we'll go into part 2. All right, here we have 2 and 5/12 minus 4 and 2/15. Again, we need to find a common denominator. I like doing the Cookie Monster method or the prime factorization. So I'm going to say 12 is 2 times 6. 6 is 2 times 3. And I'm going to go ahead and do my color codes again, just for fun. Okay, and then 15 is 3 times 5. 3's I chose blue, 2's were green. Oh, I have another number, so I'm going to pick purple for 5. There we go. Actually, that looks a little close to blue, so I'm going to pick something that's very stand apart. There we go, yellow. Okay, so now I'm looking for the least common denominator. Sorry, let's do that in red. Least common denominator. And I pick, that's really messy, all the different colors. I have greens, blues, and yellows, or 2's, 3's, and 5's. Now remember, you can only pick one plate per number. So over here, I'm going to pick this side for the 2's, and there are 2 there. The 3's, it doesn't matter. I can pick this one or this one, but not both. Either one, so I pick one. Let's go ahead and pick this one, which means I get 1. And the 5, there's only one, 5. So really, I have 2 times 2, which is 4. 4 times 3 times 5. 4 times 3 is 12. 12 times 5 is 60. So I now know my common denominator needs to be 60. And simply for space-saving reasons, I'm going to go ahead and erase this so that I can do some more work. Feel free to keep your scratch paper with all of this if that's the method you chose. Okay, so now I know my LCD is 60. Get rid of all of this. And now I need to make these denominators 60. Okay, so this one is 12. 12 times what will be 60? 12 times 5. So just for the sake of being able to write in there, I'm going to bring it down. And remember, whatever I do to the bottom, I also need to do to the top. So I'm going to multiply the bottom by 5 to make this 60, and the top by 5, which makes that 25. So I have 2 and 25/60ths. Then the other one, I need to times top and bottom over here, or if I rewrite it over here just to give myself the same space and keep it consistent, I need to multiply both the top and bottom over here by 4. 4 times 15 is 60. 4 times 2 is 8. There we go. So I have 4 and 8/60ths, and I'm subtracting. Okay, so I have 2 subtract 4. Just looking at the whole numbers here, I know that I'm going to be in the negative because I don't have enough to subtract from. I only have 2 here and I need to subtract 4. So I'm going to go ahead and line these up with the 4 being on the top, and just remembering that I will end up in the negative because I'm subtracting 4 here. Another way of thinking about that is that it's really negative 4 and 8/60. How we did it previously was adding the opposite, which makes it add a negative 4 and 8/60. You can think of it how you like, but either way, your answer is going to be negative here. But I'm going to put the 4 on the top because when you subtract, you need to have the larger on the top, and then you just go back and take the sign of the larger number. Okay, so I have 4 and 8/60 minus 2 and 25/60. Oh, here's one more step. I don't have enough here in the numerator, 8 subtract 25. So I have to borrow. I'm going to borrow from the 4 and make it a 3. And I'm going to borrow 1. But this is a special one. This one will be 60 over 60. Now, why did I choose 60 over 60? Because the least common denominator is 60. And if I'm borrowing 60 over 60, that means that this now can become, right here, 68 over 60 because I borrowed 60/60. Adding that to 8/60 makes it 68/60. So I've borrowed 1 whole from the 4. I hope that was okay. Now I have a larger number in my numerator for this top portion that I can now subtract the 25. Okay, 8 minus 5 gives me 3. 6 minus 2 gives me 4. And remember, you don't combine the denominators. You went to a lot of work to get that 60, so keep it. And then we have 3 minus 2, which is 1. But we're not done. Remember, go back and check your sign. This is going to be negative. So I have negative 1 and 43/60. And 43 over 60 is as far as it'll go. We don't need to try and reduce that. So that's the end of our answer. Okay, this is the end of part 1. I hope you join me for part 2 where we will be dividing fractions.